have to tell you, feel so privileged, so honored to be able to be up here today to talk to you, despite the fact I've only been with ACHR for about 2.5 months as its new head of government relations. I am really, really proud to be an ACHR. But before I talk to you about why I came to ACHR, I want to spend a little bit of time and talk about the certification process from my time at the FAA. I joined the Aircraft Certification Service in the FAA in 2017, late 2017, as its first Director for Policy and Innovation. Those that know the FAA know that that title by itself was a groundbreaking change for the FAA. Aligning policy, by that we mean policy in the broadest sense, the full framework for designing, manufacturing, continued operational safety of all aviation products, and the innovation side, to continuously find ways to make that framework more effective, more responsive to the developments that were going on. It's a tremendous challenge we had. To frame that for my folks, we wanted the FAA to become more anticipatory and more proactive in response to the advancements coming out of industry. So what we were charged to do, the mission was to understand the technical trends and to position the FAA to develop the framework and to implement the framework to make those advancements a reality and enter them into service. To help our team, my team, work with that, I coined a phrase. Industry innovates on technology. We, the FAA, have to innovate on policy. It's gathered a lot of legs over the years, but maybe you've heard it, but it really resonated with our folks. So what we did was, in 2018, one of the key features was I formed the Center for Emerging Concepts and Innovation. The idea of that was to work with companies as early as possible in their product development cycle. To come in, share with the new technologies they're developing, the new concepts and the new types of products, so that the FAA could in fact gain insights into those technologies and start to chart that path for certifying those technologies and seeing them implemented into the national airspace. The benefit for the company was very early on, they started to understand what the requirements were going to be to field that product, how to certify that product, and how to move it into operations. Let me contrast that with how that has conventionally worked over the years. Typically, companies will design, develop a product, they'll start constructing the product, then they'll come to the FAA. And that puts both the FAA and the company behind the 8 ball when it comes to certifying that product, because very often, there are new and novel things in that product. There are things that aren't anticipated in the regulations. There may be other issues where now they find that that product is a hard fit for the regulatory framework. But the product is already designed, built. Modifying that product is extremely difficult, so it gets very difficult to execute the changes that are needed to safely certify that product. The Innovation Center idea reversed that by, again, bringing that in earlier, reducing the risk for the companies, allowing the FAA to position itself to help bring that product to reality. So ACHR was one of the companies that truly embraced this Innovation Center concept. I still remember the first discussion I had with Adam back when ACHR was still an idea, just an idea. And we talked about how, as he started to frame out the ideas of what they wanted to pursue, to come into the FAA and start walking through and framing out how do we move this product forward. And I will give him all the credit in the world. He did it, they did it. They came in very early in the design process and worked very closely with the FAA. And it was really clear that the company was committed to a truly collaborative partnership with the FAA in designing the aircraft with certification from day one. And I'm going to turn over to Tom Muniz in a couple minutes, and he's going to share some of the details on how that really worked. and the like. So, but before I do that, I want to talk about, well, why am I here at ACHR? The first thing is my experience over the past several years has shown me firsthand the potential of advanced air mobility in eVTOL aircraft. I am a firm, passionate believer in the power of eVTOL to not just bring revolutionary, transformative changes to society, new modes of transportation, new ways to access communities and individuals, but we're going to see huge environmental improvements, zero emissions, low noise. But maybe first and foremost is I firmly believe that these vehicles are going to markedly change the bar on safety. The levels of redundancy and simplified operations built into these vehicles, lower maintenance, is going to be a game changer for the industry. And history has shown that advanced technology insertion has resulted in tremendous safety improvements. Look back at the data. These vehicles are the next implementation of that. So that was key to me, this market, incredibly attractive to me. But then I started looking at the talent that Adam has assembled. I think Michael's team that just talked to us is illustrative of the level of world-class talent that is in this company. And I understood that when I was considering coming over, but I got to tell you, coming in, the level of talent was even far beyond what I had even envisioned. It amazes me every day when I start talking to people, meeting people, understanding their backgrounds, understanding what they're bringing to the company and, frankly, to the world. I'm just amazed by the level of talent in this company. It's astounding. And the third thing is that laser focus on commercialization. That is a massive draw for me. To see these ideas, these fantastic ideas, become a reality, that really drew me to the company as well. So when the opportunity came for me to join ACHR, it was an absolute no-brainer for me to come here. And I am so happy that I did. I'm so proud to be an ACHR and so proud to have the opportunity to talk to you all today. And with that, I'm going to turn over to Tom Muniz, our Chief Operating Officer, who is going to share our experience on designing for certification from day one and the progress we've been making on that front. So over to you, Tom. Thank you.
Thanks, Mike. That did a great job setting the foundation for what we're going to talk about here today. Just to introduce myself quickly, I'm Tom Muniz. I'm the COO here at ACHR. I've been working on eVTOL airplanes for 13 years, believe it or not, which I know sounds outrageous, but it's true. And just wanted to share some thoughts opening here. I'm just so excited to be here today with Maker in the background. I know a lot of you saw Maker fly this morning, and in a couple hours, we're going to show you Midnight, which is going to be one of these first eVTOL aircraft to go to market. So having spent so much time on it, I just can't wait. I'm just thrilled to be here. Certification is actually a topic that's become very close to my heart over the years, which sounds also crazy to say, but believe it or not, it's true. Before I get into the details here, I want to make a couple quick thank yous. Guy standing over here, Eric Wright, heads our certification team. He's doing fantastic work. Couldn't do it without him. Just want to say thanks, Eric. And the tall guy next to him is Dave Dennison. He's our VP of Engineering. Leads a huge team of really dedicated engineers that are all focused on bringing this product to market and certifying it. So just want to thank you guys. So what's the point of the talk today? I wanted to do three things. One is talk more about our strategy around certification that Dr. Mike talked about a few minutes ago. But then also, we throw around a lot of terms, certification basis, G1, means of compliance, like what does all that mean? I really want to kind of strip things back and demystify the process. So we'll go through some examples and hopefully you walk away with a better understanding of what we need to do and kind of what's coming up. And then that's the last piece, is to show you where we are in the process, where we're going, and what to expect in the future. So with that sort of context, I want to dive into the strategy. And this is actually one of the things that I think most differentiates ACHR from some of our competitors or other people working in the space. So like Dr. Mike was saying earlier, a lot of people are tempted to just design an airplane, kind of think, oh yeah, I'm a good engineer. We kind of know what to do. This is going to be safe. And then they decide, okay, I've iterated, I've got something that works pretty good. Let's go to the FAA. Let's figure out how to certify it. And there's certainly nothing wrong with that strategy. I've been at places where we've done similar things. The issue, though, is that's not a particularly efficient way to bring a product to market in aerospace, right? Super heavily regulated, safety is key. So from the very beginning, from my first meeting with Adam back in 2019, one of the things that we really resonated and agreed on was the need to focus on certification from day one. So what does that actually mean, though? I'll tell you what it means. It means as opposed to designing a product, then figuring out how to certify it, what we chose to do was work really collaboratively with the FAA, figure out what all the certification requirements are, and then design in parallel to get the most efficient path to market. And I think that's pretty unique. And so far, I think it's been paying dividends. Again, that's not the only way you could do this, right? You could design an airplane, then you could take it to the FAA, figure out how to certify it. And what you'll find is, even if you did a pretty good job, there's always going to be some small design gaps, right? Maybe 10% of the design needs to change. So you might think, oh, that's fine, 10%, that's easy. But the reason I love working on airplanes is because in an airplane, everything is connected. You can't just change one thing and expect everything else to stay the same, right? A good example of that is weight. We've talked a lot about payload and how critical that is. So let's say you designed an airplane, took it to the FAA, and then you figured out, hey, I've got some design gaps, right? Maybe it's small, 10%. I need to add a couple systems. So where does the weight come from to close those design gaps? Comes from your payload. Okay, no big deal, right? Maybe it's one thing, two things. But let's say it starts to stack up and you need to change the structure, for example. We talked on our earnings call a couple weeks ago about the fact that the FAA imposed a new requirement in our updated cert bases so the aircraft would be robust to bird strikes. So for us, that was no big deal because we were already designing to that. But let's say we weren't designing to that. Okay, now we need thicker windscreens or we need to change the structure. So in an airplane, it's very easy for that kind of spiral of design to kind of get out of control. And then pretty quickly, you could have an airplane with no payload. And then what do? Well, that 10% design gap turned into 100% redesign. And so if you stack that all up in time, you can get to kind of a bad spot. And so from the very beginning of the company, we very intentionally wanted to avoid that and do everything we could to have a very efficient linear process through certification. That's really the idea, certification for day one. So in a couple of minutes, we'll talk more about that and how we think about synchronizing the design of the aircraft with certification, but I think you get the gist there. So the other theme is simplicity when it comes to certification. So that comes in a couple forms. At a high level, we very strategically chose to not, say, turn every knob up to 11 with the FAA, right? And we chose to really only push and innovate for things that were huge drivers in the performance of the aircraft. So Michael and the powertrain team did a great job showing you more of kind of the inside of what we're doing in new and novel areas around powertrain. That's an area where it makes a big difference, like they said, whether or not you really push to get high performance out of those systems, right? If we didn't have the motors and batteries, we could end up with an airplane with no payload, and that would not be very useful, right? But the other thing about simplicity is we also were very focused and have continued to be focused on just certifying in the US. And that was another thing that was very strategic. It's not that we don't think there are other interesting markets, or it's not that we think we'll never certify in other countries with other regulators. It's just we're a startup company, right? We're a lean team. We're laser focused on getting to market with our first product, and it's going to be in the US. Why in the US? It's because that's where we live, that's where we work, and we did a bunch of analysis to figure out that's actually where most of the really interesting routes are to fly. So made sense from a business perspective. And then the last point on here that I touched on a little bit is collaboration. So a couple angles here. One is, again, talking about the FAA. So we really value the FAA. We think of them as a partner. That's not to say we agree with them all the time, but it's tempting to fall into this adversarial relationship with the FAA, just speaking openly, right? Because you might come with a design you think is really good, but you might find some different opinion at the FAA. So for us, from the very beginning, again, we built this very collaborative relationship where we're showing the FAA that we're really careful, safety is our top priority, and just here's all the data, right? Here's why we think this is okay. And then we would love and welcome any opinion that they have. So that sort of collaborative approach, I think, has really been paying off so far with the progress we've made. The other angle on collaboration around certification is, again, going back to, we don't want to bite off more than we could chew, right? We want to get to market as soon as possible. In this room, there's probably 30 or 40 of our best, most important suppliers. So thank you all for being here, for coming, and for the partnerships. But again, back to what we talked about a couple times, we intentionally chose to partner and leverage the great capabilities that exist in the aerospace supply base today. It's very intentional. Again, why? It's because that speeds our path to market, makes certification easier. So now we'll kind of shift gears away from strategy and talk a little bit more about what is certification, how it works, what some of the words that we throw around are. So to kind of set the stage for that, first thing I thought it'd be useful to talk about is, when we talk about certification, what's being certified? And the reality is there's lots of different things being certified. Most of the time, we're talking about the aircraft design, right? When we talk about a type certificate, that's the piece of paper you get that says the aircraft that you've designed meets all the safety requirements and it's safe to fly. But there's a lot of other things that we work on. So a different part of the FAA works on airline operations and the rules around how these airplanes are flown to make sure they're operated very safely. Just because you have a good design doesn't mean every airplane you make is safe and well made, constructed properly. So there's other aspects of certification that have to do with manufacturing. And those are intended to ensure that the airplanes that we build match the design that's been approved. And then lastly, there's pilots that operate our aircraft. So they need to be trained and they need to operate the aircraft safely. So there's another effort that we're working on with the FAA that goes to pilot training, making sure that's safe as well. Okay, so now let's look at that in the context of the FAA. And this is probably the part of the presentation where you're saying, wow, why am I looking at an org chart of the FAA? But just go with me for a minute. So the FAA has a really big job, right? There's folks working on lots of different things. This is not the complete org chart for the FAA. This is essentially the parts of the FAA that we work with on a pretty regular basis. So you can see it spans everything from air traffic to regulations around airports. There's a huge organization called Aviation Safety that deals with both operation of the aircraft as well as the certification and manufacturing of the vehicles. There's a big legal team at the FAA that works with the policy folks, like Dr. Mike was saying earlier. And then finally, there's this cool group within the FAA called NextGen, and they're tasked with pulling together all these different efforts at the FAA to make sure that we get everything we need to go launch the business, right, across all of these groups. So, Dr. Mike talked about it a little bit earlier. If you're a new company and you want to start building a new product, who do you go to at the FAA? So you start with policy and innovation. So that box was Mike Romanowski until pretty recently. What do you do with those folks? You come in with an idea. So to put that into context, Maker, the aircraft that you saw fly earlier and the one that's in the back of the room here, that was very intentionally developed as part of our strategy to have a flying test bed that we could use to collaborate really early with the FAA as we worked through the early requirements for certification. Again, going back to that strategy where if we just jumped to the final product and said, hey, we designed this, let's certify it, clearly we'd learn stuff and we'd have to make changes. So Maker's been an invaluable asset, basically, to have the back and forth with the FAA and really accelerate the path forward for Midnight. So just kind of talking through the rest of the chart here. So you start in policy and innovation. You work with them on your certification basis. You work with them on your means of compliance. These are essentially the high-level rules that you need to design to. And then once you've got that in place, you shift to another division of the FAA. These are called the Aircraft Certification Offices. So we're specifically working with one in Los Angeles, the LA ACO. You may have heard that. So those are the folks that have all the engineering talent. They come and watch your tests. They look at your data. Those are the people that really know airplanes. And then there's other groups that work on manufacturing, like we talked about earlier, and operations. All right. So now, if we just focus on that aircraft type certification process that I mentioned earlier, kind of on the chart with the 4 pillars, I like to think of it in 2 big phases. The first phase you can think of as the requirements definition phase. What does that mean? It means this back and forth negotiation discussion around, well, what are all the rules that apply, and how are you going to show that you meet those rules? And at the end of the day, once you kind of gone through all the work, you end up with a very detailed set of information that you can use to go design an airplane and plan an airplane program. But you don't want to wait and do that all at the beginning. You kind of have to do it as you go. So after you've got those requirements in place, what do you do then? Well, you go build the airplane that you designed, and you test it, and you see, does it meet the requirements? And after that, you get all this data, you write some reports, you go to the FAA, and that's it at a high level. Once they're happy with all the documents, you're good to go. So this is the part of the talk where you're like, wow, we're still talking about this, and means of compliance and compliance finding, and what does that mean? So I was trying to think of a good analogy to kind of make it not so boring. And kind of fun fact about me, outside of work, one of my big hobbies is making pizza, specifically like Neapolitan pizza. Got a special oven, I got the special tomatoes, it's the whole thing. Another random fact is you can actually get certified to make authentic, certified Neapolitan pizza. It's like there's an international organization in Italy, it's a real thing. You gotta use the right flour, it's a real thing. So if you think about kind of that as a simple analogy here, the way to think about these first 3 phases is you're basically building a recipe, right? And certification basis, that's the very high level recipe, right? You use some flour, you use some water in the dough, some tomatoes, whatever. As you go down means of compliance, cert plans, this is getting much more detailed, right? So you've got, the certain amount of the ingredients, right? And this is how you weigh them and blah, 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 such that by the time you get to the certification plans, these are the actual really detailed executable plans to go build and certify the airplane. So then you've got the recipe. What do you do after? Well, you go bake the pizza, right? Or you build the airplane. And then when you've done that, you take a bite, right? And does it pass the taste test? And so you can think of that as kind of a simple analogy for what we're talking about here. All right. So kind of circling back to one of the themes at the beginning, this idea of synchronizing design and certification. The big thing here is, as we've been talking about, we don't want to get too far down the design path without having certainty on the certification pathway. Why? Because we don't want to have these design cycles like we talked about. But again, you can't go too far down the certification path without having the design, because the FAA doesn't design anything for you. They just won't. You have to come to them, and then they'll give you feedback. So the kind of right way to do it, we think, is staging our certification phases with our engineering development phases. So right now we're in the detailed design phase of the midnight development effort. What does that mean? It means the very high level design is very much set, and we're now working on the details, like the exact drawing for the bracket that holds the flight computer, things like that. So at the same time, on the certification side, we're working on the certification plans. You can see step 3 here, right? And all of this is kind of making that bridge from the high-level requirements phase into that implementation or compliance finding phase. So what's next for us? It's building parts and testing those parts and getting data, et cetera. Okay. So the pizza example, kind of funny. I want to give you a real example, though, now to help understand exactly what the stuff looks like. So we're going to go through a pretty simple example for how we certify structural materials for our aircraft. And don't worry, it'll be painless. 5 minutes, trust me. The cert basis. We've been talking about this for a long time. What is it, right? Well, here's a screenshot and an excerpt from some of ours. It's one document. Ours is only 42 pages. What does that mean? It's pretty high-level requirements for what the airplane needs to do. They're all safety-based. So in this structural materials example, I'm not going to read what's on the slide here, but it basically says you need to know how strong the materials are that you use, and you need to be able to prove that, and you need to take into account variation in those materials. It's like super reasonable. But it's also kind of abstract, like how exactly do you do that, right? So how you do that, that's the next step. So means of compliance. We've also been talking about this quite a bit lately. So for us, this is also one document, but instead of 42 pages, it's more like 300 pages. And why is that? It's because there's a lot more detail. So if you think back to the recipe analogy, this is, beyond we need some flour and water and yeast. This is we need, very specific amounts of things and specific processes. And in aerospace, a useful way of doing this is by leveraging existing standards, industry consensus standards, for example, like the one shown here from ASTM. So ASTM is a group that basically works across industry where companies come together, share data, and agree on, yeah, these are widely accepted processes for doing standard things. There's other ones, Alex mentioned RTCA, that's another one that's pretty common, or SAE, you've probably heard that. So here in this example, we're referencing an ASTM standard that has a bunch more detail around how you show that you understand how your materials perform. Okay, so means of compliance, got it. Okay, so certification plans. This is, again, what we're focused on today. So what I've got here is just a table of contents from one of our certification plans. This is the one that has to do with qualifying our materials and processes, same example. So for us, for Midnight, I should say, we'll have 18 of these documents. And these are pretty serious documents, right? They're like 100 pages each, give or take. And again, they have the very detailed plans for exactly what we're going to do, exactly what the FAA is going to do, and the timelines we're going to get it done. You could kind of think of it like a contract where if we go and execute to exactly what we've got laid out here, and all the data is supporting the design, then we're in good shape. So that's like pretty much the bulk of what we're working on today from a certification side, and we'll deep dive that in a minute. But just carrying forward, okay, so you've got those cert plans. Now we're shifting into the implementation phase, right? This is like the bake the pizza phase. So what do you do there? You write a bunch of test plans like this. So now we're like super in the weeds. This is a table of contents for a very particular test that we're doing to test a very particular thing about some of our materials. So, you develop hundreds of these. And then you go out and you actually do the test. So you build a test panel and you induce some damage into it, and then you inspect it ultrasonically or with thermography, whatever. You take a cross-section, you look at the data, the FAs, and they're looking at the data with you, right? And at the end, it's just all to prove you know that the design is safe and you understand what's going on. Okay, so then once you've got all that done, obviously the data has to look good. Like if you get bad data, you have to change things. But once everything looks good, it's essentially a matter of summarizing all of that into about 200 reports, submitting those to the FAA, and once those are all signed off, that's how you get a type certificate. So hopefully that gives you a better sense for where we are and what's going on. Okay, so jumping back to this idea of synchronizing the design and certification. Again, today we're in the detailed design phase. The next big milestone for us is our critical design review, CDR. That's coming up first half of next year. And on the certification side, again, we're focused on cert plans, right? Number 3 here. We've talked a lot about how the FAA made this switch from 2117A to 2117B. I don't think we need to go into those details here because we've talked about it so much, but essentially today, our means of compliance are largely understood. The FAA is going through the process of reviewing those and signing them off. But today we're working on cert plans, and we've actually submitted our first one. We did that maybe a month ago, something like that. The other point that I wanted to make on this chart is, at a high level, right, these things are serial, meaning you need to do them step by step. But in practice, a lot of this is being done in parallel. Why is that? It's because every part or system on the aircraft has to go through this process. And you don't need to wait for every single thing to be done at one step before you go to the next step. In general, you just want to make sure, again, these things are synchronized kind of between the maturity of certification and engineering, right? But that doesn't necessarily have to mean exactly one by one. So cert plans. Since this is what we're working on now, we want it to be just super transparent about exactly what that looks like. So I mentioned earlier, we've got 18 cert plans. Here they are. The one that we submitted already is our software certification plan. The reason that one was important to get on early is because software for aerospace takes a long time to develop. But the other thing we wanted to be transparent about is not all cert plans are created equal. That's not to say anything is easy, but some are much more straightforward than others. So on the right hand of the chart, we've got this idea of relative complexity. So just talking through some examples there, probably no surprise, the higher complexity things are the things that are new and novel for the FAA. So batteries, motors, or electric engines, as the FAA likes to call them. Those are the things that we've really focused discussions with the FAA on over the past year or so, because it's, the FAA doesn't have as much experience with those things. A lot of the back and forth with the FAA is about trust, right, and showing that we understand things and they understand things. So those are the areas that are more complicated. The other one is the flight controls certification effort. So in our flight control system, we leverage a lot of commercial off-the-shelf solutions, flight computers, for example, and other sensors and things like that. But for eVTOL aircraft, there's some new aspects of that, right? You saw Maker fly today. Hopefully one of the takeaways was how well controlled it was. So at least from my perspective, super stable, right, through transition. It just looked like it flew perfectly. Why is that? It's because it's got this pretty sophisticated software and sensor package on board that lets the aircraft fly much more controlled and precisely than if there were a pilot in the loop. So a lot of that for Midnight will be carried forward in the sense that while we'll have a pilot, the pilot's not going to be commanding the aileron directly, right, or a particular motor to spin faster or slower. They're sending high-level signals like, let's turn left or let's go up. And then the airplane and all its sensors and the compute platform, it decides exactly what the best way to achieve what the pilot wants is. So a lot of that learning on Maker transfers forward. Okay, but last point here, there are other certification plans that are low complexity, again, not because they're easy, but because strategically we've chosen to take a more conventional path or partner with some of the companies in this room, right? So the flight deck, for example, we're not developing brand new hardware for the flight deck, right? We're working with well-established, top-notch suppliers. Environmental control system, similar. You get the idea. All right. So what's next and where are we today? The next big thing we should look out for us is to see our airworthiness criteria from our updated cert basis published in the Federal Register. That should happen within the next few weeks. That's not so much a big milestone for us in that it helps us move forward. It's more you should keep an eye out because there's interesting stuff in there, right? And it just essentially shows where we are. I mentioned earlier our means of compliance. So the idea there is, again, this change from 2117A to B essentially reset some of the approvals. So the FAA is now going through those and approving them, mostly an administrative thing. Goal is to still get that done this year, but it's going to come down to how quickly we in the FAA could get through it. But then more critically, it's the cert plans we just talked about. So today, all of those 18 cert plans are drafted. They're all in really good shape. We're essentially ready to submit those to the FAA as soon as it's practical, just based off of their bandwidth and ours, and kind of which systems we're going to choose to focus on at any given time. But then after that, we start to get into the really exciting stuff. So next year, we're going to be building our Midnight aircraft. We're going to be building conforming hardware, meaning hardware that's built to the exact engineering definition. We're going to start doing tests. We're going to start taking certification credit for those tests, right? Starting to write some of those reports that we talked about, all working towards our goal of receiving type certification for Midnight before the end of 2024. And today we feel really good about our position there.